So for example 2 here, we're not doing what we did in the previous examples, which were just evaluating, writing in radical form instead of fraction form, and then evaluating. Here, all we're doing is we're kind of working backwards, but we don't need to do any evaluation. So it's written in radical form. Therefore, all we need to do here is put it back to exponent form. So I can take the x, that's on the inside, and remember how I said if it's to the power of here, actually the better way to remember it is whatever is in this valley here is in the denominator. So I know that the 4 is in the denominator, and these ones that aren't with the square root, without these root symbols, it's not a square root, this is actually the root power of 4, a fourth root, whatever's not there is on the numerator. So in this case it's a 3. And that's all there is to this. So if it was on the numerator, we would have put it with the x, and when it was on the denominator, we would have kind of put it, what I like to say, in this little valley. So same thing with this, with b. If it's in the valley, that's on the denominator. In that case, it's a 5. And then the other ones, those aren't in these little valleys. Those are on your numerators. Now, when you have an exponent to an exponent, one of the rules is the power rule. That's 3 times 10. So you have to go 30. 3 times 10. So maybe I'll write that. I'll go 3 times the 10 all over the 5, which in this case is 30 over 5. Which can be reduced. 30 over 5 is actually, 30 over 5 is reduced to just 6 over 1, or in this case just 6. So let's keep going here. So here we've got x, and our denominator is going to be a 3. And our numerators are 6 times 4. Because remember, our numerators, we can write them on the inside of the root, or we can write them on the outside. And I always said I like to write them on the outside. You could write them on the inside, but when you evaluate things, it's too complicated. So you often see that I kind of circle those to let the reader, let myself know that, oh, those I need to multiply, in which case it's going to be 24 over 3. Now 24 over 3 can be reduced. That's actually x to the power of 8. Which is a lot simpler to write, actually, than what this is. Now we've got 2 of these symbols, these radical symbols. And it's not written here, but you need to remember that this symbol here has a 2 that's in front of it. We just don't ever write the 2. So our denominators are actually 2 different numbers. It's a 5 and a 2. And because it's a fifth root to the power of a half, the 5 and the 2, those can be multiplied together. And then your numerators are right here. That's going to be 3 times a 4. So really what you have is, I guess, 12 over 10. And that can be reduced. Those can both be divided by 2. So 6 over 5. It can't be reduced anymore, but that's it. Now, maybe it's helpful to write here, but those will go together, and those will go together. So these are our numerators right here, and then the ones inside the valleys, those are our denominators. So 5 and 2. Okay, well, let's keep going here. Rewrite using the exponents, and then we're even going to do some more simplifying. So this is denominator is a 3, numerator is a 7, times denominator is also a 3, numerator is a 5. Now, when the bases are the same, which they are, x and x, we are able to put them together, and the exponents rules say that if you multiply and the bases are the same, you can add the exponents. Now, they need a common denominator, but lucky for us, they already have it. So 7 plus 5 is 12, and you don't go 3 plus 3, you leave your denominator the same. So 12 over 3 is an x to the 4. So that worked out really nicely, but they all won't work out quite that neat, or quite that simple, I should say. So here, the denominator is 3, numerator is 4, so 4 thirds. Here, The numerator is a 2, denominator is a 4. So you could reduce this to 1 over 2, but in the end, if we're going to put these together, which is what it's asking us to do, we'll have to get a common denominator anyways here. So 4/3 plus 2 over 4. Again, if I made it a 1/2, I need a common denominator of 3 and 2, but this is just 3 and 4, so it doesn't make any sense to reduce that right now. But you could. So I do need a common denominator, so I'm going to have to make it 12. So I'll times this by 3 and times this by 4. So it looks to me like I have 16 over 12 plus 6 over 12, which gets us 16 to 22 over 12. And that can be cut in half to get 11 over 6. So I've reduced it. Now I think I can leave it in, it wants it with exponents. Yeah. So I mean, you could make this, the denominator is a 6 and the 11 is the numerator, or I guess you could put the 11 on the outside. But it's asking us to leave it in exponent form. So we'll just leave it as this. So we took two radicals. Both of them had different denominators, 3 and 4, and we've merged them into together with a denominator of 12, which actually was reduced to 6. So let's keep going here. This is an x, denominator is a 4, so 3 over 4. And here the denominator, oh, it doesn't say, it's actually a 2. So 5 over 2. Now, the exponent rules say if the bases are the same, they are, x and x. If you're ever dividing, you can subtract both exponents. However, these can't be subtracted unless they get a common denominator. So I'll times this side by 2, and then they'll both be a 4. So 3 over 4 minus 10 over 4. Which, if you subtract them, will be, I was about to write 7 there because it gets you a negative 7. So this is x to the power of negative 7 over 4. So it wants me to leave it in exponent form, which it is. However, common practice, best practice is to actually put it down below. And the reason we want it down below is because we want it to have a positive 7 over 4. So because of the negative exponent, which is the first time this has happened, we want to bring this down below. So this is over 1, you bring that thing down below, and it becomes a positive 7 over 4. Now, is there any more here? Do I have one more? Yeah. One more here. Now this has a bunch of things. We're multiplying up here, and we're dividing. So if you think of this as your first one, you are going to multiply, so we'll add, and then you're going to divide, so we'll subtract, and then we're dividing again, so we'll subtract again. So it looks like we have an addition, and then there's two things on the bottom that we're going to subtract. So, oh, this has no number here, so this is a 2. Oh, this has no number, so that's a 1. Okay, so we've got x, we have a 1 over 2, and let's try this other one, x, which is a 6 over 3. And then x, this is a 4, so 3 over 4. And then x, 5 is on the bottom, so 3 over 5. So if I'm going to write this as 1, so I have the half, and because the bases are all the same, because we're multiplying, we can add the 6/3, so we can add these exponents, but then we can subtract the 3 over 4 and then subtract the 3 over 5. Okay, good grief. So we're going to need a common denominator here. Now, did I write 6 over 3? I did. Is it 6 over 3? Yes. Okay. So I need a common denominator between 2, 3, 4, and 5. Now, I know the common denominator between 4 and 5 would be 20. Does 3 go into 20? No, it doesn't. So if it's 20 times the 3 is 60. So 5 goes into 60 12 times. 4 goes into 60 15 times. 3 goes into 60 20 times, 2 goes into 60 30 times. So they all can go into 60. So we can multiply this by 12, because that would get us 60. Multiply that by 15, because that would get us 60. Multiply this by 20. 3 times 20 is 60. And this is going to be times by 30. So there's lots going on here. But what we have is a 30 over 60 plus 120 over 60 minus 3 times 15 is 45 over 60 minus 3 times 12 is 36 over 60. So there's a lot going on here. So now I can go 30 plus 120 is 150. 150 minus 45 is 105, and then we can minus 36. So 5 minus 6 can't do it. So borrow from that. It's going to be, instead of a 10, it's going to be a 9. This is going to be a 15. 15 minus 6 is 9. 9 minus 3 is 69. So I have 69 over 60. And I don't, can those be reduced? They can. They can both be divided by 3. So I have x equals 33 over 23 over 20. And that can't be reduced. So that is my final answer.